All right, considering silicon again, so remember this is our electron configuration. Now this is okay for silicon because there aren't many electrons, but as we move further down the periodic table, elements have an increasingly large number of electrons. And writing out the entire configuration becomes cumbersome, and there's a lot to write down. So what chemists do is that we use what's called the noble gas shortcut to represent the electron configuration of the inner part of the electron cloud. Remember that on your periodic table, the column on the right, the last column, these are your noble gases. Gases that typically don't react with other elements, hence the name noble gases. Now what we're going to do is we'll use the symbols of these noble gases to represent the inner energy levels of electrons within this atom. So let's look at neon, for instance. Neon has an electron configuration of 1s2, 2s2, 2p6, which happens to be the same as silicon in its first and second energy levels. For those levels, silicon and neon have the same electron configuration. So the noble gas shortcut works like this. You'll swap out these, 1s2, 2s2, and 2p6, and you will put in the symbol of the noble gas in brackets. And that noble gas is used as a stand-in, as a shorthand, for those inner energy levels of electrons. For silicon, the 1s2, 2s2, and 2p6. So silicon's electron configuration, using the noble gas shortcut, would be Ne in brackets, the symbol for neon, 3s2, 3p2. That's the noble gas shortcut. Now, for any element on the table, if you're wondering, well, what noble gas do I use? Well, you look at the element, here's silicon, and you work down or backwards by atomic number, 14, 13, 12, 11, 10. And you do that until you come to a noble gas, which in this case is neon. That's the noble gas that you'll use for that element. And then for the electron configuration, you write all the energy levels and sublevels that come after that noble gas. So in the case of silicon, neon stops at 2p6, so we need to write 3s2 and 3p2. And there you have it. Again, that's the noble gas shortcut for electron configuration.